Hey, hi. Okay, so today we are going to learn probability 2. Okay, chapter 18. So we are starting from probability 2 part 1. So 18.1. So probability of an outcome can be done by this one. Okay, if we are going to determine the probability of an event, okay, if the two outcomes are the same, we can say that the outcomes are equally likely. Okay, equally likely. Okay. Okay, for example, if you are tossing a coin, okay, we only have two outcomes. One is head, one is tail. Okay, so one of the outcomes can only be 1/2, right? Okay, 1/2 outcomes. Either you get heads or either you get tails. Okay, so this is an equally likely possibility for the occurrence. Okay, how about choosing a random card from a set of cards numbered from 1 to 6? Okay, you have 1 until 6. Okay, every number has equal possibility. Okay, if you take 1, if you choose 1 or choose 2 or choose 3 or choose 6, all of their probability will be 1/6. Okay, so this is also an equally likely occurrence. Okay, so for a sample space S, which consists of equally likely outcomes, the probability of an event is actually number of outcome of event A over number of outcomes of sample space. Okay, probability A is actually number of A over number of S, where 0 is smaller or equal to probability of A or smaller or equal to 1. Okay, where if probability of A is 0, means that the event A certainly will not occur. Okay, if probability of A is equals to 1, the event A certainly will occur. Okay, let's see example 1. Okay, 16 cards written with the letters from the words Kuala Malaysia. Okay, as shown in the above diagram are put into a bag. A card is picked at random from the bag. Calculate the probability that the card shows a vowel. So, okay, so now first thing you need to do, you need to look for the sample space. Okay, sample space is this. Every cards you have are your sample space. Okay, so you have 3 A's, you have 2M, okay, you have 5 A's, okay, then you have 2M, okay, the rest are only 1. Okay, if you want to get a vowel, how many vowels you can have? Okay, 1, 2, 3, 4, 4, okay, 5, 6, 7, and 8. Okay, so I have 8 vowels here. Okay, how many cards I have? 16 cards. So the chance of me getting a vowel is actually 8/16. Okay, how about consonant? Consonant also 8. Okay, so also 8/16. Okay, a letter after the letter Q. Okay, according to alphabetical order. After Q, we have what? O, P, Q, R, S, T, U, V, W, X, Y, Z. So 9. R, okay, I have R. Okay, R, S, T, U, V, W, X, Y. Okay, so I have 4 letters. So it's actually 4/16. Okay, remember, you have to simplify the outcomes. So so our outcome will be 2/1, 2/1, and 4/1. Okay, so this is how you do probability. Next, ping pong balls labeled with the number shown in the above diagram are put into a box. So a ball is thrown at random. Calculate the probability that the box shows number less than 15. So number less than 15, you only have 11, 13, and 17, right? Okay, so we only have three ping pong balls out of 6. So 3 out of 6, it will be 1/2. Okay, let's check our answer later, okay? How about prime number? Prime number 11 is prime number, 13 also, 17, 19, 23, 29, all are prime numbers. So it's actually 6/6. So I'm having 1. Okay, even number, we don't have any even number here, so 0/6. So answer will be 0. Okay, let's check our answer. Oh, okay, number less than 15. Oh, I'm wrong here, sorry. I counted 17 as less than 15. It's actually 2 out of 6. So 1/3. Okay. So obtaining prime number, all are prime numbers. So 6/6 is 1. So it means that this event will certainly occur. Okay. How about even number? Even number is 0. So 0/6, so it's 0. So it certainly will not occur. Next, we have to calculate the expected number of outcomes. So expected number of outcomes of an event A, okay, is actually probability of A times number of trials. Okay. The probability that a disk gets produced by a factory is defective is 1/20. So if 5,000 diskettes are produced by the factory in a certain period of time, estimate the number of diskettes that are defective. Okay, so we have the probability, we have the number. So the probability times the number of sample space. So we can find the number of diskettes that are defective. So it's 1/20 times 5,000, you have 250. Okay, next. A basket contains red apples and green apples. If an apple is picked at random from the baskets, okay, the probability that it is a red apple is 4/5. If there are 84 red apples in the basket, calculate the total number of apples in the baskets. So, red apples is 84. Okay, green apples we don't know. Okay, so you substitute whatever you have in. So we have number of red apple equals to probability of red apple times number of sample space. So I don't know my number of sample space, right? But I know number of my red apple, 84. I know my probability. So number of sample space is actually 84 divided by 4/5, means 84 times 5/4. So my number of sample space is actually 105. So this is my total number of apples in the baskets. Next, okay, a box contains 7 red bulbs, 5 green bulbs, and X blue bulbs. If a bulb is thrown at random from the box, the probability of obtaining a green bulb is 1/3. Okay, find the value of X. Okay, so let R become red bulb, G become green bulb, okay, B become blue bulbs. Okay, so my number of sample space is, I have 7 red, okay, I have 5 green, I have X blue. So this is my sample space. Okay, 7 plus 5 plus X. Okay, our probability of green bulb is 1/3. Okay, so it's actually probability of green bulb is actually number of green bulb over number of sample space equals to 1/3. Okay, so number of green bulb is 5. Okay, sample space is 7 plus 5 plus X equals to 1/3. Okay, and then you cross multiply. So 12 plus X times 1, still 12 plus X. 5 times 3 equals to 15. So x equals to 15 minus 12, it becomes x equals 3. Okay. Example 6, we have easy access. So 10 cards over here. So we have few additional cards, okay, put into that one. Okay, so at first we have 10 cards. At first we have 10 cards. Then after that, additional cards E added. Okay, so we put as X. So it's actually our number of sample space. Number of sample space is actually 10 plus X. Okay, and then if you get E, it becomes 3 over 7. Okay, how many E at first? Okay, we have 1, we have 2. So now number of E is 2 plus X. Okay, so probability of E is 3 over 7. So probability is actually number of E over number of sample space. So 2 plus X over 10 plus X equals to 3 over 7. Okay, or they use K, never mind. You can use X, you can use K, all the same. Okay, then you cross multiply. Okay, then you have 7K minus 3K equals to 30 minus 14. So you have 4K equals to 16, K equals to 4. So the number of additional cards is actually 4. Okay, there are 36 balls in a box. 15 are squash balls and the rest are golf balls. X tennis balls are then put into the box, okay? So probability of obtaining a golf ball is 2 over 1, and 1 over 2, okay? Find the value of X. Okay, number of squash ball we have 15. We have 36 balls, right? So number of golf ball is 36 minus 15, so it's 21. Okay, so number of tennis ball, I don't know, so it's actually X. So number of sample space is 36 plus X. Okay, so obtaining a golf ball probability is 1 over 2. So probability is number of golf ball over number of sample space equals to 1 over 2. So it's 21 over 36 plus X equals to 1 over 2. Cross multiply. 21 times 2 is 42. So X is equals to 42 minus 36. X is 6. Okay. Example 8. Okay. A dart is thrown at random onto a board, shown in the above diagram. So we have to calculate the probability that the dart hit the shaded region. So first we need to find the area of the smaller circle. Then we need to find the area of the larger circle. Then the large circle minus the small circle, we have this part. Once we have this part, this area, then this area divide by the whole circle area, okay, will be your probability. So probability the dart hit the shaded region is area of shaded region over area of larger circle. Okay, so 462 over 616 equals to 3 over 4. Okay, so this is 18.1 probability of an outcome. So, okay, so for you guys try to do 1, 4, 5 at first. Okay, and also 10, 11, 13, 16, and 17. Okay,